Confined Space Entry Training. A preliminary course to understanding OSHA requirements. For all personnel. Presented by Safety Through Teamwork. Nothing is so important that it cannot be done safely. About this training program. This is an online training for OSHA 1910.146 Confined Space Entry. Defines terms, provides information about regulatory requirements. This program is just the start. Your employees need to be trained personally on how to put on their gear, about confined space entry permits, how to operate other confined space entry equipment. Training outline. Introduction, definitions, OSHA regulations, general hazards, permits, atmospheric testing, safety procedures, training and duties of the confined space entry team, review and quiz. Introduction to Confined Space Entry Regulations. What is a confined space? Few entrances. Poor or no ventilation. Possible toxic or explosive gases. Oxygen can be displaced or depleted. Displacement can happen when you generate fumes and there is no ventilation. Or when the nitrogen confined space definition is large enough that an employee can enter and perform assigned work. Has limited or restricted means for entry or exit. Is not designed for continuous employee occupancy. Examples of confined spaces. Storage tanks, pits, silos, vats, tunnels, sewers, shafts, exhaust ducts. Not typical confined spaces. Some may not think of these as confined spaces. Excavations. Top is open but air does not circulate. Fumes from equipment or soil can choke your worker because there is no draft down. Trenches. Fumes can accumulate, liquids can fill the space, and earth could cave in killing the worker. Regulatory requirements. OSHA, Employee Safety Permit Confined Spaces. 29 CFR 1910.146. The employer must assess the workplace to determine if hazards are present that necessitate the use of PPE. Why do you go into confined spaces? Inspection, repair, maintenance, new construction, emergency rescue. All confined spaces must be identified and a sign must be posted prominently in front of it. What does the OSHA 1910.146 regulation require? Written program, permit system, training and education, emergency planning, rescue equipment/training. A written permit system is a very important aspect of your confined space entry program. This permit needs to be filled out prior to any entry into a confined area, and it needs to be approved by your supervisor. Who is covered and who enforces this regulation? Municipalities, by the state. States must comply with federal regulations. Private businesses, by federal OSHA. More than 224,000 establishments are covered and 7.2 million workers. Confined space entry regulations cover the entire USA. What happens if regulations are not followed? Loss of life or permanent injuries. Resulting lawsuits. On top of all that, OSHA fines $7,000 per violation for not having a permit program. $70,000 and up to $250,000 and jail for individuals if a fatal accident happens and there is no confined space entry permit documentation. You must have a written confined entry program that identifies all permit spaces, prevents unauthorized entry, establishes a permit system that ensures pre-entry testing and monitoring of atmosphere, provides protective equipment to employees, Ensures one attendant is always outside watching. Establishes rescue and emergency procedures. See regulations for more requirements. Employer responsibilities. Provides training for CSE team. Has a backup rescue team. Provides proper equipment including rescue tripods, monitoring equipment to test air, harnesses, lifelines, permit forms, protective clothing, air packs, ventilation fans, air hoses and blowers. When is training is required? Prior to assigning someone to job duties that include confined space entry. When the job duties change. When there are changes in permit space program. When the employee's job performance shows deficiencies. Training is required by OSHA regulations. Training should include step-by-step procedures for permit completion, detailed procedures for using respirators, monitors, harnesses, other equipment, rescue preparation, dry runs, testing and certification. Hands-on training with equipment is the most important. Note that this slideshow is not sufficient to complete training. Equipment required by OSHA. OSHA requires that the employer provide adequate protective equipment including masks and air packs, harnesses and lifelines, lockout/tagout, protective clothing, detection devices, other equipment. The next few slides will provide definitions and guidelines for selection. Equipment, harness lines. A harness is worn by workers to facilitate rescue or retrieval. Lifeline is attached to D-ring. Use power winch to lift workers from confined spaces. Wristlets are sometimes issued to allow lifting by wrists. Equipment, air hose. Air hoses attached to source outside the space may be used when workers enter spaces with hazardous atmospheres but can't have the restrictions of a SCBA. Air is supplied via an air hose from an outside compressor or blower. The worker wears a tight-fitting mask. It is crucial in these cases that the observer keep an eye on the worker at all times. Equipment, winch and tripod. A winch or other power device is often used to lift workers by their harness from confined spaces that were entered from the top. This device may be required when entry into a hazardous atmosphere is made where there is a possibility of an entrant passing out. Equipment. Lighting, monitors, first aid kits. Battery power lighting should be used by the observer for best view of worker. If entrant carries lights, make sure they are explosion-proof. A first aid kit should be available close by to treat injuries on the spot. Air monitors may be used to test or monitor atmosphere by entrants or observers. Personal protective equipment. Gas masks. HNS officer is to evaluate or test atmosphere in confined space prior to entry. Use gas mask appropriate to those conditions, or if no time for testing, assume the worst and wear an air pack. Written plan should define typical hazards for each confined space. However, first test atmosphere before each entry, because conditions may have changed. Personal protective equipment. Air purifying masks. Masks that contain a filter cartridge are especially designed to absorb or adsorb the contaminants in the atmosphere. These devices are very specific to a particular chemical, such as chlorine. The limitation is that it does not filter out other chemicals or makes up for lack of oxygen. Cartridges have limited capacity to absorb materials and need to be replaced periodically or after each use. Personal protective equipment. Air purifying mask. Precautions for using an air purifying mask. Follow instructions. Pay attention to mask ratings. Clean all masks thoroughly. Use fresh cartridges each time. Personal protective equipment. Self-contained breathing apparatus, or SCBA. A self-contained breathing apparatus is used to enter areas where a hazardous atmosphere is present. The system supplies air from a tank on the worker's back into a tight-fitting gas mask. This device is used in lieu of an air hose and for certain hazardous atmospheres. Need depends on tests of current conditions. Self-contained breathing apparatus, or SCBA. Typical appearance. Other equipment. Communications. Lighting. You will need a device for communications in order to relay information to rescue teams, etc. Don't rely on electronic devices to communicate with the entrant. You must keep an eye on him/her at all times. You will need radios or cell phones to get ambulances or other help, etc. An air horn is a great way to sound an alarm when cell phones don't work. So be prepared. Personal protective equipment. Protective clothing. Each site will determine what level of protection is needed for entering specific process areas. These are mapped out and indicated in the health and safety plan. Classification of the confined space may be upgraded, if current conditions have changed. Classification is generally A, B, C or D. Permit space hazards. Hazardous or explosive atmosphere. Too little or too much oxygen, flammable or toxic air. Engulfment. Danger from unexpected movement of machinery. Electrocution. Heat stress. Becoming wedged into a narrow space and suffocating. Flammable or explosive atmospheres result from leaks of flammable materials, byproducts from welding, vapors from painting. Even if you are painting in a room that is not considered a confined space, the ventilation may not be strong enough to remove the vapors and you will need additional forced ventilation. Always consider using paints that do not generate harmful fumes instead if possible. Electrical hazards can kill. Poorly grounded equipment. Broken wires. Wet ground. Electrical hazards are especially dangerous when entering a dark and confined area. Wear insulated gloves and shoes to avoid shocks. Disconnect power prior to entry. Mechanical hazards can injure or kill. During a confined space, entry machines starting up unexpectedly could be lethal. If a machine starts in a cramped area, the person can't get out of the way. Without a lockout and tagout system, someone can start it accidentally. Beware of equipment left on. Equipment not tagged out. Moving parts. Sharp objects. Noise hazards prevent communication. You may not hear when someone needs help. So be sure to establish well understood hand signals in noisy areas. Their hearing protection may prevent them from hearing. Go over the hand signals before entry. Do not rely on electronic devices. Never take your eye off the person entering the confined space. Engulfment kills fast. Water fills space, drowning. Gas fills space, suffocating. Hazardous chemical fills space. Chemicals, water, or gases can come into the space faster than rescuers can pull out the person. This is why a harness is so important to pull them up quickly. Note, harnesses may not work with mud or solids, such as in collapsed trenches. Preventing engulfment. Blank off. Don't just shut off. Water flowing into a tank or a toxic gas line could engulf the entrant faster than a rescue can be made. To blank off a pipe means that you will be physically blocking possibility of flow. Just closing a valve may not be sufficient. If a worker is going to go into a space where engulfment is a possibility, sources should be blanked off positively. Often people don't go as far as blanking off, which leads to disastrous results. Sharp objects and other hazards. When preparing confined spaces for entry, file down or remove any sharp objects that could injure personnel or puncture air lines. SCBA training. Workers required to wear this equipment should not have any facial hair that will break the seal between the skin and the mask. An escape bottle should be used as a backup to the SCBA in the event of equipment failure. While 10 minutes is the required time, you should time escapes in trial runs and allow for physical condition of worker and other contingencies. Trial runs should be made on how to put on the SCBA equipment. Steps for confined space entry. You must follow proper confined space entry steps as required by your written plan. Confined space entry procedures are different for each site. Testing the atmosphere and ventilation prior to each entry. Test atmosphere prior to each entry. Determine if oxygen levels are safe. Are toxic gases present? When testing the atmosphere, make sure you place the monitor in various spots. Certain hazardous gases may accumulate in pockets. Sparks lead to explosions. Sparks from tools in poor condition or not approved for confined space work can lead to fire or explosion. All tools and wiring used should be carefully inspected and explosion-proof. Ventilation systems. Ventilation systems are required. Ventilation systems are used to force oxygen into the confined space. Even if prior to entry the atmosphere is okay, the oxygen can be quickly used up as you breathe or work in the space. Even if the space is opened on the top, air must be forced into the space to provide oxygen and force out toxic gases. Monitoring should continue while work is being performed. Reducing risks of hazards to others and crew. Post signs to alert employees of the dangers of confined spaces. Use barriers to keep unauthorized employees out of permit spaces. Develop and use a written space entry program. Conduct air monitoring and other tests to identify and evaluate hazards in each permit space. Ventilate, eliminate, or control the space's atmospheric hazards before entry into the space. Permit requirements. Permit space. Purpose, date and authorized length of entry. Authorized entrance and supervisor by name. Hazards of the identified space. Control and isolation methods. Acceptable entry conditions. Results of initial and periodic atmospheric testing. Rescue and emergency services to be summoned. Communication procedures. Equipment to be provided. Planning prior to entry. Prior to entry, the types of operations which are to be conducted within the space must be determined. You should enter your plan in the permit form. Plan how you will proceed if an accident were to occur. Fixtures, dividers, or equipment within the space may contribute to the hazards. Typical procedures for confined space entry. These are typical, but each confined space has special requirements. Plan ahead. Step 1. Fill out the permit prior to each entry. Required. This includes names of personnel, location of confined space, reason for entry, training, verification of entrance, rescuers, observers. Step 2. Make sure enough personnel is available. At least one observer for each entry is required. Observer is not allowed to go into the space. Step 3. Preparation of permit space. Notify all affected departments. Post signs and put up barriers to protect entrance from traffic and pedestrians. Empty space of any materials that may be hazardous. Add emergency contact telephone numbers. Atmospheric testing, see next slide. Step 3A. Atmospheric testing. Continuously test and monitor air in all areas before entry. Make sure that the oxygen content is between 19.5 and 23.5%. List any toxic materials that could be present and their permissible exposure limits. Evaluate heat stress potential. Control any hazards present before entry. Evacuate the space and cancel the permit if air becomes hazardous. Step 4. Blank off sources of engulfment. Blank off sources of engulfment like pipes, bins, sources of gases positively. Don't just close a valve, insert a blank. If this is an entry done all the time, a system of positive sealing needs to be installed. Step 5. Eliminate hazards, lockout tagout. Lock out and tag the equipment properly to eliminate possibility of it starting accidentally and injuring workers. Step 6. Obtain a hot work permit. Hot work permits are required by OSHA. Obtain a hot work permit for welding or other hot work. Separate the confined space permit. Permit forces you to go through checklist. Step 7. Ventilate and test again. Do not go in immediately. If tests prove the atmosphere to be unacceptable, ventilate until acceptable and test again. Wait a long period to determine if hazardous gases are leaking in. If they continue to leak in, protection is needed. If in doubt, wear a SCBA for protection. Step 8. Make sure personal protection is working. Document all material in permit. Verify proper operation of equipment. Make sure all entrants are trained in its use. Go over hand signals. Step 9. Go over the plan. Go over the plan verbally, and write it down. Any special considerations for entry should be written down. Personnel should be given a copy and briefed. You may have a ready plan for each site that you can modify. Remember to use native language if person speaks in foreign tongue. Go over hand signals. Never take your eyes off your entrance. Step 10. Alerting others. Alert everyone. Construction crews. Other workers that frequent the area. Pedestrians. Post signs. Obtain signed foreman release. Step 11. Check your rescuer's readiness for the day. Make sure your rescue crew is trained and ready to perform a rescue in the event of a problem. Be aware if anyone is absent or in training. Clearly assign who will be doing the rescue work for the day. Record this information in the permit. Continuous monitoring during entry. Simultaneously monitor atmospheric hazards. Methane. Carbon monoxide. Flammables. Hydrogen sulfide. Variable oxygen levels. Safety procedures during entry. Authorized entrants can enter a permit space only after it's been tested and found safe for entry, and a permit has been completed and posted. The assigned entrant must know what equipment to use and how to use it. Once prepared, entrant must complete the assigned task as quickly and efficiently as possible. Alert the attendant immediately if you recognize a sign or symptom of exposure to a dangerous situation. Training and duties. Duties of the entry supervisor. Verifies that the permit is filled out completely and all safety steps listed are taken, then signs the form. Checks conditions to ensure they stay safe throughout the work. Sees that any unauthorized people are removed. When work is complete, cancels the permit and concludes the operation. Training and duties. Duties of the attendant. Maintains an accurate count of who's in the space, monitors activities inside and outside of the space, and stays in touch with the entrants. Keeps unauthorized persons out of the way and away from an occupied permit space. Orders evacuation of the permit space. Entrants show signs of behavioral effects of hazard exposure, or an outside situation that could endanger the workers in the space. Summons rescue and emergency services when needed. Training and duties. Duties of the entrant. Knows the hazards of the space and signs of exposure. Follows personal protective equipment training carefully. Keeps in contact with the attendant, leaves space at once if instructed to do so. Is always ready to evacuate quickly. Leaves the space and tells the attendant if there is danger. Emergency and rescue procedures. Self-rescue. An entrant evacuates the space with no help. Non-entry rescue. Only workers trained in rescue can enter the space for the purpose of rescue and only when there is another attendant present.